When we look up at the night sky, stars seem like small points of light. But, of course, this is a deceptive impression. Stars are colossal objects at great distances from us. Particularly interesting are giant stars, such as Betelgeuse and Antares. These giants are kind of living monuments of cosmic evolution, as their incredible size and brightness give us a unique opportunity to study the processes occurring in the late stages of stellar life. Let's delve into the world of these stars and see what they are remarkable for, what are their features, and why they are of such interest to astronomers. Betelgeuse, a star on the verge of explosion. Betelgeuse, located in the constellation of Orion, is one of the most famous giant stars. It is a red supergiant star, about 700 times larger than the Sun. If Betelgeuse were at the center of our solar system, it would engulf the orbit of Mars and possibly even Jupiter. Since Betelgeuse is at the end of its life, its explosion as a supernova is only a matter of time. Betelgeuse features: distance and size. Betelgeuse is located about 640 light-years away from Earth. Its radius is about 764 times that of the Sun, and its mass is 10 to 20 times that of the Sun. Variability and luminosity. Betelgeuse is a variable star, which means that its brightness fluctuates. The reason for these variations is due to internal processes occurring in the star's core. The dying process. Betelgeuse is a red supergiant, indicating that it's in the age stage. It is burning its fuel faster than stars like the Sun and may soon go supernova. When this happens, the star will explode and become one of the brightest objects in the night sky. It will be visible even during the day. This process could happen either tomorrow or in a few tens of thousands of years. Antares, the heart of the scorpion. Antares is another famous giant star that is located in the constellation Scorpius. The name Antares comes from the Greek anti-Ares, which means opposing Mars, as Antares resembles Mars with its reddish hue. This star is a red supergiant, like Betelgeuse, and it is also on the verge of its death. Features of Antares: distance and size. Antares is located about 550 light-years away from us. It is 700 times larger than the Sun, and its luminosity is 10,000 times that of the Sun. Satellite and system. Antares is a binary system, which means it has a companion, Antares B, a hot star of spectral class B. This companion is about 550 astronomical units away from the host star. Evolution. Like Betelgeuse, Antares is in the final stages of its life. Its inner core is shrinking, while its outer layers continue to expand. As with Betelgeuse, Antares has only a short time left before it explodes into a supernova. What is the uniqueness of giant stars? Red supergiants like Betelgeuse and Antares have a special place in astronomy because these stars reach their gigantic size in a very short time by cosmic standards. To better understand their uniqueness, let's look at their life cycle. Stars like Betelgeuse and Antares begin as huge clusters of hydrogen and helium. Due to their enormous fuel supply, they quickly progress to the supergiant stage, burning off the hydrogen in their core and moving on to heavier elements. As such stars burn more and more fuel, they expand to an incredible size, but their core becomes denser and hotter. Eventually, they will reach a stage where they can no longer hold their outer layers together, leading to a huge explosion, a supernova. The explosion of such stars produces not only a bright glow, but also the release of huge amounts of heavy elements such as carbon and oxygen, which then become the building blocks for planets and eventually life. How do giant stars affect the universe? Cosmic pollution. The explosion of supernovae produces heavy elements that are then spread throughout space, replenishing the surrounding space with the material needed to form new stars and planets. Energy contribution. The explosions of giant stars release enormous amounts of energy that affects everything around them. This process triggers new waves of star formation and forms galactic structures. Exploring dark matter and energy. Giant stars and their explosions help scientists explore the fundamental laws of the universe, including the nature of dark matter and energy, which make up about 95% of the mass energy of the universe. Questions to ponder. What are the benefits to humanity of knowing about the structure and evolution of giant stars? How important do you think the role of supernova explosions is in shaping the conditions necessary for life? Conclusion. Studying stars such as Betelgeuse and Antares allows us to better understand not only the processes occurring in space, but also important stages in the evolution of the universe. These giant stars are at a critical point in their lives and are about to explode, bringing enormous changes to the surrounding space. A supernova explosion is not just the destruction of a star, but the birth of new materials from which new planets and possibly life may one day emerge. Giant stars like Betelgeuse and Antares are not just objects for astronomers to study. They are a kind of cosmic beacons that remind us of the incredible scale and dynamics of the universe. When we look at these stars, we literally see the past. The light that reaches us has traveled for hundreds of light years. In fact, the stars may have changed, perhaps even exploded, as their light traveled to us through space. Reflecting on the giant stars, there is a sense of deep connection between all the elements of the universe. After all, everything our planet and ourselves are made of was once inside stars that went through the process of exploding and dispersing their elements into space. Betelgeuse and Antares are living testimonies that even in the brightest and most powerful objects there comes a moment of transformation that leads to new worlds and materials for life. Giant stars also make us think about the temporality of existence. These stars burn brighter than our sun, but because of this they burn faster, passing their life cycle in a matter of millions of years, while our sun will shine for billions of years. Perhaps this is a clear example of the fact that a bright life is not only happiness and success, but also responsibility. After all, giant stars leave important elements for future planets and stars after their death. Observing the processes occurring with such stars, we can feel not only our place in the vast universe, but also realize that each star, planet, even the smallest atom around us has its own story. These stories intertwine to create a truly majestic picture that inspires us to continue to explore and seek answers to questions that humanity has not yet solved.